Okay, now we understand how to illustrate a business process. The main objective of this topic is how to analyze this process. So we have to understand some different ways to measure the performance of a business process. To do this, we will use a set of measurements called process metrics. So we are going to define a few new terminologies and the measurements, and after that we will solve some example questions to learn how to use those new metrics. So let's define a few terminologies first. Working process. What is working process? In short, working process is called WIP, W-I-P. And the WIP is units that have entered the process but have not left the process. What this means? A process, now we understand that there's a set of activities or operations, right? So let's say there is a task A, and let's say task B and task C. Very simple process with three different tasks. And then we can just say that the boundary of this process is, let me use different colors here. So this is a process, and the process is composed of three different tasks. Okay. So when we use this process, we are transforming inputs into outputs. That means materials are coming in and we are producing some outputs as finished goods. So when materials comes inside this process, these materials will move through all those different tasks, and finally it exits this process as a form of finished goods. Work in process means when those units or materials comes in this process, so now it is inside this process boundary, but it still does not leave this process, then all those materials in the middle of the process is called working process. There are two different types of working process. The first one is called raw material. Second one is buffer inventory. Raw material means particularly inside this process, materials are in front of first task, in this case, task A. So those materials just enter the process, but it was not processed. It was not, transformed yet. Then we call this type of material as raw material. And then as these materials are moving through the process, it's going to be transforming, right? It's going to be assembled and it may be painted or whatever. So, but still, if it does not leave this process, in other words, if it's not finished goods yet, we name those inventory, those work in process as buffer inventory. I know in accounting, we use some different definitions. In accounting, usually we differentiate work in process from raw material. However, in our definitions, let's say work in process is kind of an umbrella term, and it can be further specified into two different types. One is raw material, and the other one is buffer inventory. And the last one, the last type is when these materials are finally transformed into finished goods, final products, we say this is finished goods, final products. In summary, there are three different types of materials in a process. First, there is working process, and the second, there is a finished goods. The working process can be further specified into, yes, in front of the first task, materials are called raw materials. And if materials are in the middle of the process, we name it as a buffer inventory. Okay, so we just defined the three types of materials in a process. Let's move on. Next one is arrival rate. and the output rate. Sometimes we use the term input rate instead of arrival rate. Arrival rate means rate of incoming units to be processed, and the output rate is the number of units produced per unit of time. Both arrival rate and output rate, we are looking at the number of units. However, it's not just the number of units. You have to note that we are looking at given time how many units are entering the process. Again, output rate, given time how many units are being produced by the process. That is arrival rate and output rate. Okay, so where you can measure this arrival rate and the input rate. Previously, I mentioned that there is a process, then we have some tasks connected inside this process, right? So materials are moving through this process. So particularly in front of first task, raw materials comes in, and those materials will be transformed. And so there may be different types of buffer inventories in the middle of the process, and finally finished goods will be produced, and those materials will exit this process, right? So a process is given like this, then we can measure how fast materials are coming in. Where? In front of the first task for this process. That is called arrival rate. So for example, you can say that, hey, 10 units are coming in, but don't forget there should be some time. Not any given time, but you must fix a unit time. For example, let's say given 1 hour, 10 units are coming in. This is a kind of a good measurement, how fast materials are feeding in this process. Also, after going through this process, you can measure the output where? At the end of the process. So at the end of the process, particularly you may want to see how many finished goods are being produced. So you can also, yeah, similar to arrival rate, you can say that, oh, every 1 hour, I can see that there are 10 units of finished goods are currently being produced. Then this is output rate. So again, arrival rate and output rate, where you can measure. Arrival rate is at the beginning of the process. Output rate, end of the process. Both measurements look at how many units are comes in and comes out for given time. Let's move on. Next one is capacity. Capacity, the measurement of capacity is kind of similar to arrival rate and output rate. Why? Because capacity also measure how many units per given time dimensions, but a little bit different angle. What you want to see here is always you need to remember this keyword maximum. Capacity represents maximum rate of output. So this is important concepts. Here, maximum means when the working condition is idealistic. You can see the maximum units you can make for a given time period. That is called capacity. But the actual output could be different from the capacity because you cannot always, produce the maximum units. For example, let's say if there is a machine, if you fully use this machine, you can see that the maximum rate you can produce is, let's say, 15 units per hour. However, certain conditions, one day, you could not fully use this machine, then instead of 15 units, you may produce only 10 units per given 1 hour. So in this case, capacity means not 10 units per hour, but 15 units per hour. That is the maximum rate of output rate. Okay. The abbreviation to represent this capacity is CAP. So capacity is potential maximum rate of output, and usually units of outputs per unit of time. 10 units per minute, or for example, you can say 20 units you can make given 1 hour. It doesn't matter whether you use hour or minutes, but just remember, given time dimension, how many units you can make, particularly what? Maximum. That is the definition of capacity. Capacity is measured for a task or an entire process. What this means is a process is given like this, and if there is a process, inside the process we have different tasks, right? So for each task, let's say A, B, C, each task or each machine may have different capacity. For example, A may be very, fast machine. So let's say you can produce 15 units per hour. Then this is the capacity of A. For B, let's say it is a little bit slower machine. Then the capacity may be different, like 10 units per hour, something like that. So for each station, you can measure the capacity. But when you look at a process, you are looking at all those tasks together. Then what would be the capacity of this entire process? Actually, we can answer to this question when we look at the examples following slides, but I will not explain all the details at this moment.